For centuries, human cultures have had various ideas of how old the Earth was and how long it had existed. In many cultures, the Earth and the universe are thought to be eternal, with no beginning and no end, so that it's not a question that even occurs to them. In Western cultures, the idea of the beginning comes from the book of Genesis, which has influenced most of our thinking for centuries. Genesis 1:2 describes how the earth was without form and void, followed by a series of other creation events and culminating with the creation of humans. Many theologians argue that the earth had been made perfect and that the evidence of erosion and destruction of the earth's surface was due to Adam's sin. The other biblical story that was influential in early thinking about the earth was the story of Noah's flood, a universal flood that covered the entire earth for weeks and weeks. This quote by the natural historian James Woodard in 1695 is representative of thinking of the time. The terraqueous globe is to this day nearly in the same condition that the universal deluge left it, and being also like to continue so till the time of its final ruin and dissolution, preserved toward the end where it was first formed. The first scholarly attempt to put an age on the earth was done by Archbishop James Ussher of Armagh in Ireland. Ussher's ideas represented the leading scholarship of the time, which used the Bible as a precise chronometer, but also attempted to find other sources to date the earth. Like other ecclesiastical scholars of his time, Ussher used the begat method, where he looked at the age of the patriarchs in the Bible and what age they gave birth to their children. For example, Methuselah supposedly lived 187 years before he begat Lamech, and Lamech lived 182 years before he begat Noah, and so on. However, this method only gets you so far because the Bible has many unnumbered gaps in its record. So Ussher used other clues, what was known of Greek, Roman, Persian, and Egyptian ancient history, and came up with the date of October 22nd, 4004 BC at 9 in the morning. Estimates such as this were accepted by most scholars until the late 1700s, when the independent thinking James Hutton of Edinburgh, Scotland, came up with a different approach. A product of the Scottish Enlightenment, Hutton was more interested in applying natural law and natural processes to understanding the earth, rather than following biblical tenets. He used what is now called uniformitarianism, using the processes of the present to understand the processes that have occurred in the past. He watched as streams flooded his property in eastern Scotland and deposited layer upon layer of sediment with every flood event, and realized that if you apply this to the past, the rock record must have thousands and millions of years represented by each layer of sediment that shows up. A thick stack of thousands of feet of sands and gravels and muds must represent millions of years. Hutton saw the striking rocks of Sicker Point, Scotland, and recognized what is now called an angular unconformity. Such deposits could only be formed by layer sequences being laid down in rivers or in the ocean, then being folded and tilted by immense forces, then being eroded up as they were uplifted, then down dropped again and buried by later sediments. If modern rates of these processes were any indication, such events took millions of years, not just 6,000 years. As Hutton wrote in Theory of the Earth in 1785, the result, therefore, of our present inquiry is that we find no vestige of a beginning, no prospect of an end. This was still the prevailing idea until 1864, when William Thomson, later Lord Kelvin, decided to use physical estimates to determine the age of the Earth. He assumed the Earth had formed from a molten state at a certain temperature, and that no additional heat was being provided, and then using heat flow measurements that were available at the time, he calculated how long it would take for the Earth to cool down from its original molten state. His estimate was that the Earth had only formed 20 million years ago. To the leading geologists of the time, this was far too short. Charles Darwin had great difficulties with the idea. As he wrote in a later edition of On the Origin of Species, "Here we encounter formidable objection, for it seems doubtful whether the earth, in a fit state for habitation of living creatures, has lasted long enough. Sir W. Thomson concludes that the consolidation of the crust can hardly have occurred less than 20 million years ago. As Darwin goes on in this passage, clearly a 20 million year old Earth was not enough for the slow process of evolution to take place. Most geologists of the late 19th century also disagreed with Kelvin's estimate. They saw the enormous thick pile of rocks, like then the Grand Canyon, and could not imagine this immense pile of rocks took less than 20 million years to form. Most geologists, like Charles Doolittle Walcott of the Smithsonian Institution, thought of the Earth as immensely old because they would add up the maximum thickness of the Cambrian strata, the Ordovician strata, and so on, and come up with estimates that are in the tens of millions to hundreds of millions. In 1899, the Irish chemist John Joly estimated the age of the Earth based on the salt content of the ocean at around 100 million years old. He assumed that the oceans had started as fresh water, which is true, and then they reached their present salinity about 3.5% by continually eroding salt from the land. However, his estimate of 100 million years of Earth history was way too young, because salt does not just continually accumulate, but much of it ends up in salt deposits, and it's in equilibrium at around 3.5% for most of Earth's history. Geologists and Lord Kelvin were at an impasse until 1897, when Henri Becquerel discovered radioactivity. Within a few years of Becquerel's discovery, New Zealander Ernest Rutherford of Cambridge University realized that the decay of radioactive elements, such as uranium, were the source of the X-rays that Becquerel had observed, but also were the source of the heat that powered the Earth. In addition, the predictable rate of radioactive decay would prove to be the method by which the Earth could be dated. In a famous story, Rutherford was giving a lecture on radioactivity in 1904 when he saw Lord Kelvin sitting in the audience. As he recalled, to my relief, Kelvin fell fast asleep, but as I came to the important point, I saw the old bird sit up, open an eye, and cock a baleful glance at me. Then a sudden inspiration came, and I said, Lord Kelvin had limited the age of the Earth, provided no new sources discovered. That prophetic utterance refers to what we now consider tonight radium. Behold, the old boy beamed upon me. Indeed, that had been the problem with Kelvin's estimate all along. He assumed that no additional source of heat was available, when radioactivity, in fact, is what powers the heat of the Earth today. In 1907, Yale chemist Bertram Boltwood noticed that older rocks had most of uranium in them, but younger rocks had very little uranium and lots of lead. He reasoned that the uranium must spontaneously decay to lead, and that the ratio of uranium to lead would be a direct measure of how long the rock had had chance to undergo radioactive decay. Boltwood never did have a chance to follow up on this insight, so it fell to a young graduate student from Imperial College London by the name of Arthur Holmes to work it all out. By 1912, he established that there are rocks that are at least 2 billion years old. Today, we have rocks that date back to 4.4 billion years old, and there are moon rocks and meteorites that date to 4.567 billion years old. We are back to Hutton's insight of the Earth being immensely old, or as John Playfair wrote, the mind seems to grow giddy looking so far into the abyss of time.